So I am going to explain all the questions regarding gyroscope. A uniform disk with radius r and a mass m is mounted centrally on a horizontal axis of negligible mass. Means mass of the axle is considered to be negligible. Why this is necessary? This is necessary because this will interfere in the I. And even if the mass was given, so you have to find a common center of this uniform disk and axle. And after finding the as it is centrally, it is the uniform disk is centrally located and axle suppose homogeneous, then the center of the gravity will lie here. So no worries due to this about in this axis, and plus disk about its this axis. So you found the G, or you find the I. What is I? I is the polar moment of inertia, because I polar mass moment of inertia. Polar means about this axis, about the axis which it is rotating, means spinning axis of spinning which it is rotating. And length of 1.5 r. The disk spin counterclockwise about the axle with angular specificity omega when viewed from the right hand side bearing. So this is the right hand side bearing. From here we are seeing it as counterclockwise from right hand side, means go to right hand side. This counterclockwise means L is this side, so L on this side. The axis precesses about a vertical axis at omega p is equal to omega by 10. The axis in the clockwise direction when viewed from the above. When viewed from the above, as this is the camera viewed from the above, this is anti-clockwise. So clockwise means this. This means in this direction. Now, what is use of this is I will explain. Just remember clockwise direction when viewed from the top. So suppose this is the disk, so this is the shaft. As shaft is rotating, because shaft only precesses, try to precise or precesses. Bearing of course allows some displacement, and due to some displacement there is of course a reaction. So clockwise from this means the shaft will go like this. So this L was in this direction, L nu is in this direction, delta L is in this direction, action torque is in this direction, and reaction torque will be in this direction. Let Rp and Rq positive upwards, means upward is taken positive, be the resultant reaction forces due to mass and the gyroscopic reaction forces effect at the bearing P and Q. Assume this the ratio of larger to smaller bearing forces. No worries. This is the figure. So it goes like action torque is this direction, reaction torque is in this direction. So take a right hand from the center of gravity, from the center like we did in airplane. You need this direction, means this means the right hand side bearing पे जो gyroscopic effect लगे वो नीचे की तरफ और दबाने की कोशिश करेगा. So if we take a right hand side bearing, उस पर एक फोर्स लग रही है mg, और एक जो gyroscopic effect है वो भी से नीचे ले जाने की कोशिश कर रहा है. So gyro effect. And if we see on this, we need this direction, this. So one force which is mg, gravity is trying to pull it down, means mg मतलब ड्यू टू इसका वेट की वजह से यहाँ पे ग्रेविटी की वजह से फोर्स लगी वो, और एक गायरोस्कोपिक इफेक्ट की वजह से फोर्स लगी वो. बोथ आर ट्राइंग टू पुल इट डाउन, मतलब दिस इज पुलिंग इट अप, दिस इज पुलिंग इट डाउन. Now what is asked? Find the value of the reactions. First of all, in initial case when the disk was stationary, this is the weight which is m kg. which is m kg. So mg by mg is acting downwards. So simple case, simply supported beam mg by mg. So here will be mg by 2, here will be mg by 2. mg by 2. This is the reaction given by the bearing. What actually is asked, I don't know. Is it asking reaction of the bearing with the resultant reaction forces due to mass at bearing P and Q? So is it like saying it is asking effect of the mass and gyroscope on bearing, or the after the effect what is the reaction of the bearing? Is it asking that? I don't know. But suppose I am finding the what suppose I am finding this thing. The reaction of the bearing means the reaction of the bearing when the gravity and the gyroscope affects. What does bearing do? So mg is pulling it down, when the gravity is pulling it down, so it will, with the force mg by 2, it will act, bearing will oppose mg by 2. And if the this gyroscopic couple is trying to pull it up, so bearing will pull it down. So here net force is, suppose he said net force, take this as positive, this is negative. Of course he took upward as positive and downward as negative. So mg by 2 plus minus rc, and for this bearing both are trying to pull it down, so bearing will cause upward reaction. So it will be plus mg by 2 plus rc, reaction due to gyroscopic couple. I will show what is the force. We have to find the force. This is the couple. Now this is the thing. Mg is it comes out to be 5m. This will come out to 5m plus minus how much it comes, rc. Now in the case when there is bearing here and a gyroscopic couple is acting, where does the gyroscopic couple acts? On the disc, and on the disc at this point at the center of gravity it acts gyroscopic couple. Suppose this is the gyroscopic couple acting. So this is case of simply supported beam in which there is a couple at the middle. So couple will be like suppose this is RA, reaction due to bearing due to for this couple. So RA into net moment here at 0, RA into this minus this is moment, so here it will come. So RA is equal to gyroscopic couple divided by length. So R is equal to this. So you put, it comes out to be 10m. So minus 5m means downward it is 5m, means bearing is trying to pull it 5m downwards. This bearing is trying with applying a force 5m downwards, and here it comes out to be 15m, means bearing is pushing 15m. So it's plus 15m, it's minus 5m. So the answer is minus 3. So is it correct answer? Let's check. I omega omega p, this comes out to be, this comes out to be 15 mr, okay, 15 mr by 1.5 r, as I told. Length of the couple 10m. This is comes out to be this. So this comes out to be minus 3, and yes, this answer is correct. So first of all in this question was we have to write polar moment of inertia. Polar moment of inertia we have to write. Yeah, polar moment of inertia. I represent polar moment of inertia, and polar moment of inertia for a disk about its own center of axis is mr square by 2. That's why I use mr square. For a solid disk, for a ring it is mr square, but for a solid disk it is mr square by 2.